So whenever we see an x term times a trig function or an e to the x or natural log or something, that typically signifies that we're going to need to possibly do integration by parts multiple times, right? So I see an x squared here, so that tells me that I'm probably going to need to do integration by parts twice. And if you listen to the other integration by parts video, we did this example, right? We'd said that you had to use it twice, but we'd already done the second part, so we just substituted in the answer. So I'm going to show you something called the tabular method, the tabular method, whatever you want to say it as, right? And this is going to be used for multiple repetitions of integration by parts. Right, so this is really helpful if you know you're going to use multiple iterations. Of integration by parts. It's also just a great way to organize your work, and I find that a lot of times students just make sure that they don't miss anything this way. So, right, it says tabular, right, meaning table. So we're going to make a table, and our table is going to have 3 columns in it. So the one column we're going to have is we're going to pick our u. One column is we're going to pick our dv. And then we're also going to add in a sign column. So we're going to go row by row. So you always want to pick your, I'm going to make these black because I don't like that the colors don't match. Okay. Right. So if you have a polynomial portion like an x squared, you definitely want to pick that to be your u. So my first u would be x squared. And my first dv is going to be the sine of x. Right, technically dx. Okay, so the thing about the sign column is you're always going to start positive. Okay, so for your u column now, you're going to take the derivative until you get to 0. So I'm going to even write that. All right, take derivative until you get to 0. Okay. Right, so the derivative of 2x, right, it's 2x. The integral of 2x is 2. I keep saying integral because we're integrating. The derivative of 2x is 2, and then the derivative of 2 is 0. So now that tells us how many rows we're going to need, so I'm going to fill in the rest of my signs. So you always alternate your signs. So I go positive, negative, positive, negative. We're going to alternate signs. And then you want to integrate multiple times until you fill in your dv column. So the integral of sine, and I'm going to just kind of work this out on the side. So the integral of sine of x dx is negative cosine of x. You don't need to worry about your pluses or anything right now. So then I have 2 more to do. So I'm going to integrate negative cosine of x dx. Right, and if you can do these in your head, you don't need to write the integrals out on the side, but I'm going to show all my work for this. So that's going to be negative sine of x, right? Technically plus c, I'll be a good mathematician and put those on here. And then the integral of negative sine of x dx is just cosine of x. That c really looks like an e in the front. Okay, so now our table's filled in. So the way you kind of fill in, you use the table to put your answer together, is you start here, you start in the first sign and you go to the matching part of u. I held down too long, whoops. And then you go down to v. So my first term of my answer is going to be positive x squared times negative cosine of x. And then I'm going to keep doing that. So you go, boom. So I'm going to get, right, minus 2x times negative sine of x. And then write that, right? And so then I'm all done. So I'm going to get plus 2 cosine of x, right, all plus c. So I'm just going to kind of move all this down so I can simplify my answer. Oh no, I lost my plus c's. Right, so if I go here, right, and simplify, I get negative x squared cosine of x plus 2x sine of x plus 2 cosine of x plus c. Right, so we did this problem earlier, so I'm going to actually scroll up in my document to that, right? So you can see that it's the same exact answer, right? There's the problem, right? Same exact answer in that lower lime green box, right? But we didn't have to write all of the integral steps. So if you can do this, if this makes more sense to you, you can do this on every problem. If you're taking the AP exam and you have to do an integration by parts on a free response question, this is acceptable work, but you need to show the table. You can't just like magically come up with the answer. Plus, you're probably stressed out when you're taking the AP exam, so like it's very easy to make mistakes, so just write it all out. So I'm going to do one more example of this. So x cubed cosine of 4x. I'm going to make it a little harder. Okay, so I'm going to set up my 3 columns. So I'm going to have my signs, going to get my u's, and I'm going to get my dv's. Okay, so my u is going to be x cubed, and then I'm just going to differentiate so I can figure out how many rows this thing's going to have. So I'm going to get 3x squared, then I'm going to derive and get 6x, 6, and then 0. So then I'm going to fill in my signs. So I always start positive, and then I alternate. Now, integrating here, right, if you're getting really good at u-subbing in your head, this shouldn't be too bad. But otherwise, you're going to have to write it out, and that's okay. Right, so my first dv is going to be the cosine of 4x. Okay, so if I go to integrate the cosine of 4x dx, right, if I were to do a u sub here, I would get my u is 4x, so my du would be 4 dx, which means that I need 1/4 of my du to be equal to dx. So this is going to become 1/4 the integral of the cosine of u du. So overall, I'll just stick with orange, whatever. We're going to get that this is equal to, I'm going to come down here, I'll just resize it later, 1/4 times the sine of u plus c. And if I go back to my x's, that's 1/4 times the sine of 4x plus c. Okay, now let's make that fit in that little space. So my next line is going to be 1/4 sine of 4x. There we go. So if you're starting to get the pattern, right, since it's just 4x in the inside, that means every time I'm going to integrate, I'm going to multiply my answer by 1/4 again. So if I go to integrate 1/4 sine of 4x dx, okay, so the integral of sine is negative cosine. I'm going to leave the inside the same. I had a 1/4, I'm going to multiply it by another 1/4, so I'm going to get 1/16 plus c. Okay, so I've got negative 1/16 cosine of 4x. Right, so this is a great method to use if you're like super fast at basic u-subs. Okay, so if I integrate negative cosine, I'm going to resize this because it's getting a little messy. Okay, so integrate negative 1/16 of cosine of 4x. Okay, so I have negative 1/16 out front. The integral of cosine is sine. I'm going to get sine of 4x, right? I'm still going to put my plus c in there. And because of that 4x, I need another 1/4. Negative 1/16 times 1/4 is negative 1/64 of sine of 4x. Okay, and one more time. There we go. The integral of negative 1/64 sine of 4x dx. Okay, so I got negative 1/64. The integral of sine is negative cosine of 4x plus c. So these are going to become positive. And then divide by another 4, so multiply by 1/4. 64 times 4, that's 256. So I'm going to get 1/256 cosine of 4x. Okay, so I'm actually just going to leave my table there. take that down here, resize this just to make it look the same as everything else. There we go. Okay, right? And so then we're gonna put our answers together. So zoom. So I'm gonna get x cubed. Actually, let's just go down here, make a new line. So I'm gonna get x cubed times 1/4, so x cubed over 4 sine of 4x. Okay, our next line, I'm gonna get negative 3x squared times negative 1/16. So the negatives are gonna cancel and become positive 3x squared over 16 cosine of 4x. Okay, zoop. I'm gonna get minus 6x over 64 times sine of 4x, which those are both even numbers, so I'm going to go ahead and simplify them in my next line. And then zoop, we get minus 6 over 256 cosine of 4x, all plus c. So then I'm just gonna rewrite the first two terms and then simplify my fractions. If I was doing this on a free response for an AP exam, would I need to simplify? No. Right, so those are both divisible by 2, so this is going to be 3x over 32 sine of 4x. If I divide that by 2, yep, so it's going to be 3 over 128 cosine of 4x plus c. Right, so without even writing all of the integration by parts, because this would have been 3 iterations of integration by parts, so we didn't have to do all those like messy integrals inside of an integral. So now we can just use